In this example, we're supposed to find a whole bunch of angle measures, find the indicated angle measures in parallelogram ABCD. And yes, this symbol here in front means parallelogram. So let's look at this diagram. Here they have marked a number of angles. They've also shown us the diagonals, but we need to find more things. First of all, if we're dealing with a parallelogram, then we know that these two sides, for example, have to be parallel. And as soon as we hear parallel sides, remember you guys, that means we can think about our special angle relationships. Think about your parallel sides and your transversal. They make a nice Z shape together, and that Z shape will always tell us something about alternate interior angles. Remember, and alternate interior angles are congruent. So this angle of 80 degrees is an alternate interior angle with the angle down here, angle ACB. So this one also has to be 80 degrees. We do have another pair of parallel sides, sides AB and DC, and therefore we can make another Z shape for another set of alternate interior angles. This angle ABD with 23 degrees is alternate interior to CDB, so this also has to be 23 degrees. And now we have two angle measures in this triangle down here. That means we can find our third angle. We got 180 minus 117 minus 23, and that is going to be 40 degrees. That means this angle down here is 40 degrees. And we can keep going. Without even worrying about parallel lines, we have two diagonals that cross each other, and that gives us vertical angles that are also congruent. So angle E up here has to be 117 degrees. And now we can find 117 plus 23, which is 140. That means that our missing angle in this top triangle has to be 40 degrees as well. See how it goes? We can go from different directions and we can start filling all those things in that we need. So let's see what we got so far. We were supposed to find the measurement of angle AEB. Angle AEB is this angle, and we found it. It's 117 degrees. Then we were supposed to find the measurement of angle BAE. BAE is 40 degrees. We found it. Next, we're supposed to find the measurement of angle EBC. EBC. Oh, we don't have that one yet. Well, then let's look. How can we find it? In this triangle on the right here, we are missing two angles. Not only EBC, but also BEC. But looking at BEC here, we see that it forms a linear pair together with AEB, which we know. And linear pairs add up to 180 degrees. They are supplementary. So 180 minus our 117 degrees, that is 63 degrees. So we found this angle. And with two angles in a triangle, we can find our last one. 180 minus 80 minus 63 is 37 degrees. So now we have a measurement of angle EBC that is 37 degrees. And last but not least, measurement of angle ECB. ECB, we had already found that one before. It is 80 degrees. So see how it helps when we mark our diagrams with all information that we are given or information that we additionally find. That way we can always refer back to it when we are supposed to put our answers down. In example 16, we are given the vertices of a quadrilateral, and we're supposed to plot the points and draw the quadrilateral in the coordinate plane, then find the slope of each side, and lastly answer the question, is ABCD a parallelogram? So let's get to it. The vertices of the quadrilateral are A is at -1 and 3, B is at 4, 3, C is at 2, -1, and D is at -3, -1. Now let's draw ABCD, and let's go in the direction of the letters A to B to C to D and back to A. This is our quadrilateral, and now we're supposed to find the slope of each side. Remember, slope is rise over run. So what is the slope of AB? We're going to abbreviate M for slope. The slope of AB. How many steps are we rising to go from A to B? This is actually a horizontal line. And if you remember Hoy and Vux, you remember horizontal lines have a slope of 0. So the slope of AB is 0. What about the slope of DC? Slope of DC is also 0 because it's a horizontal line as well. Now let's find the slope of DA. In order to go from D to A, we go 1, 2, 3, 4 up and 2 over, 4 over 2, which is 2 over 1 or simply 2. And the slope of CB, we go up 4 and 2 to the right again, 4 over 2, 2 over 1, 2. So now we have to say, is ABCD a parallelogram? Use your info from part B to explain why. We know about a parallelogram that the opposite sides have to be parallel. And what do we know about the slopes of parallel sides? Parallel sides have the same slopes. So we saw up here in part B that AB and DC have the same slope. So AB is parallel to DC. And as it happens, DA and CB also had the same slope. So we have both pairs of opposite sides are parallel. And if both pairs of opposite sides are parallel, that means ABCD is a parallelogram. So I'm going to write, therefore, yes, ABCD is a parallelogram. Question answered. Well done. In our last example for today, we are given 3 vertices of parallelogram ABCD. And again, note this symbol stands for parallelogram. So we have that information. And we are supposed to find the coordinates of the missing point D. But first we need to plot the points that we actually have. A is at -2, 7, -2, 2 to the left, and 1, 2, 3, 4, 5, 6, 7 up. There is our A. B is at 3, 6, 1, 2, 3 to the right, 1, 2, 3, 4, 5, 6 up. C is at 5, 1, 2, 3, 4, 5, and 1. And we are supposed to find point C. Now let's connect the points we have to get a better sense of what our parallelogram is going to look like. So point D is supposed to be somewhere down here, it would seem. And as we've seen in the previous example, our opposite sides, since they're parallel, have to have the same slope. So let's look at the slopes of the two sides that we have. And I'm going to count only this ones, starting from B going to the left, because I have C but I don't have D. So from B to A, I go 1, 2, 3, 4, 5 steps to the left and 1 up. That means from C to D, I would also technically have to go 1, 2, 3, 4, 5 steps to the left and 1 up. So this is where I think D should be. But let's also check with our other two sides that are supposed to be parallel. From B to C, I go 2 to the right and 1, 2, 3, 4, 5 down. That means that from A to D, I should also have to go 2 to the right, 1, 2, 3, 4, 5 down. And indeed, I get exactly to the D that I found before. So here's our point D. Let's make our parallelogram. And we were supposed to find the coordinates of our point D. And those are 0 and 2. That's it for today, you guys, and I will see you in class.